In this video, we're going to look at business examples of predictive regression. We're not looking at any specific regression algorithms such as linear regression or neural networks, but rather the general class of business problems that could be resolved or helped by various predictive regression algorithms. So first, let's look at the general idea of predictive regression. First, we're talking about prediction. This means that we're looking at past data that we have in order to predict what we expect future data to look like. That's the framework we're talking about. So this is predictive analytics. Second, we're talking about regression. And regression means that what we're trying to predict are specific numeric values rather than limited classes or categories. If we were predicting classes such as yes or no, true or false, well, that would be a classification problem. But here we're predicting numbers such as how many customers will come to our store, or maybe how long it takes for a project to be completed. So not categories such as will the product succeed or fail, yes or no, or will the customer buy, yes or no. Those would be classification problems. And finally, this is in the framework of supervised learning. Supervised learning means that there are true answers based on which we can compare to see if the computer's predictions are correct or not. There are true answers from the past, and we can look at how well the computer can predict, and in the future we'll see the true values. We can tell how close the computer was to getting the correct answers or not. I'd like to further clarify the distinction between classification and regression as predictive goals. So first, the basic goal of classification is to predict classes or categories, whereas the goal of regression is to predict numbers. But it's a little bit more than that. When we look at the evaluation criteria of what is a good classification model or a good predictive model, classification really looks at all or nothing. Have you successfully predicted the category or not? So this illustration here kind of shows this point. If you're shooting targets, here what you have is either you hit or you miss. It doesn't really care that much how close the hit is, but if it hits one of the red ones, it's a miss. If it hits the green one, it's a hit. And that's like classification. It's not a matter of closeness or not, it's a black or white scenario. If it's a category you hit that you wanted, it's true. If it's not a category you wanted, it's false. Close doesn't count. In contrast, with regression, the closeness does matter. And so here's another target where there are different points based on how close it gets. The bullseye is the yellow, then closer is red, blue is outer, and then all the way white is a hit, but not a very good one. And that's more like regression, where it does make a difference how close you get. And in fact, in regression, it's very, very rare to get an exact perfect estimate of the correct value, such as in this illustration, none of the arrows actually hit the yellow spot, but a few did hit red, and some were even closer to the center than others, and those are more valuable. Here, you get more points the closer you are, and that's what regression is like. You know that you're probably not going to predict the exact number, but the closer you are, the more valuable, the more appreciated that prediction is. So that's a clearer distinction between classification and regression, especially from the perspective of their evaluation. So now we'll continue with some business examples and scenarios to show where an organization might need regression to solve some of their problems. This example is from related to customer help desk, which covers human resources, operations, and supply chain management. And help desks generally supports the sales, well, or the after sales efforts of companies, whether they're providing services or products. When consumers need help or have questions, the help desk is there to help them and provides an overall satisfying customer experience. Now, help desks are fairly expensive to maintain because well trained uh, help desk support specialists are, well, should be well paid, and they are a valuable resource, but that is costly to the company. So, on one hand, the company values their costs or should value their costs, and so wants to have enough help desk people for when customers want to call because the number of people staffing the help desk determines how long customers wait. It's the difference between a customer waiting 1 or 2 minutes before talking to someone versus waiting 10, 15, or 20 minutes, which most customers would not even wait that long, and that would greatly negatively affect their customer experience. However, so the company that is staffing these employees, on one hand, wants to have enough help desk people so that customer satisfaction remains high, but on the other hand, does not want too many people because if there's too much staff and some staff is actually waiting around with no customers reaching them, well, that is a lot of wasted resources or wasted funds because these people need to be paid for sitting around doing nothing. So being able to estimate how many people are needed, let's say how many people need to be staffed the next week, uh, that is a very specific estimate. And usually the estimate would be how many staff hours are needed. And because this is an estimation of numbers, this would be a regression problem. Now, the criteria for this might be the day of the week. Certain days of the week might require more time. There might be factors such as perhaps there's been a recent product released, and with a new product, the company would expect more people, more customers asking questions and needing help. So they might need to increase the amount of staff at that time. There might be a holiday season when people tend to buy more of the product or service. But based on these various factors, the company tries to estimate the number of staff hours, and that is a regression problem. Here is another example from supply chain management and operations, but dealing with the supply of machinery, but also with some staffing implications. So when companies have expensive machinery, uh, to usually for manufacturing some sort of product, uh, the their profits and their efficiency depends very much on these machines working effectively and continually. And in order for them to work effectively, they need to be maintained regularly because machines will break down. That's normal, especially if they're working hour after hour nonstop. And but in order to minimize the breakdowns, there needs to be preventive maintenance that checks that everything is working okay before the breakdown happens. Because usually, when a breakdown happens, it's much more expensive because it takes quite a bit of time for well, first to get a technician there, and then for the technician to diagnose the problem. And sometimes it might need special parts that need to be ordered. And so that's further delay. And expensive machines that are not working are costing the company a lot of money. So by being able to estimate in advance how long a machine typically takes before it breaks down, the company could save a lot of money. Qualified technicians are quite expensive, and having too many maintenance checks could be wasteful. They will catch every error, every problem before they come, but it's another kind of cost. So if the company can accurately estimate, let's say perhaps every 25 days on average is when a machine breaks down, then based on that, they could say, okay, we need maintenance checks every 20 days rather than every week. So being able to accurately estimate the time to failure, because that is measured in number of days or number of hours since the last preventive maintenance check, that is a regression problem. This example from supply chain management concerns heating oil, or en français c'est fuel, which is often used to heat homes. It's not the most environmentally friendly approach, but it is very cost effective in a lot of places because based on the price of oil, heating a home with this technology is cheaper than a lot of other options and often cheaper than direct electric heating because electric heating is actually very inefficient because it's often most electricity means are generated with heat that's converted to electricity and then transferring that and then convert the electricity back to heat is just a big waste. So burning fuel right away, even though it's not the most environmentally friendly approach, is much more energy efficient and much more cost efficient. So a heating oil provider wants to estimate how much heating oil its customers might need because it needs to know how much to buy from the refinery, and it also needs to strategize based on the oil prices, which go up and down, how much oil to stock when prices are low and how much is excess. And so, based on historical data, the information from its customers, uh, it can look at all the different customers it has and considers the quality of the insulation of their homes, the average monthly temperatures. Perhaps this year is colder or warmer than the last year. They look at the historical heating purchases from those customers, the number of occupants, their average age, because typically older uh, customers tend to need more heating. So, based on this information, they're trying to estimate how much oil they need to stock up to be able to supply their customers for the next month. Because their estimate is an estimate of how much oil they need, it's a specific number in barrels of oil, that is a regression problem. So, with these examples, hopefully you have a better idea of where regression would be a useful technique to solve various kinds of business problems.